All right. So the next thing is here about the chain rule, one important technique of differentiation, because a lot of functions are composite functions, okay? And we need to know some technique, or let's say develop this technique to deal with this kind of differentiation. Now, again, let's just start with this example. One example is here, capital F of x is equal to sine of x squared minus 4, right? Here our function is sine. Inside from function, also we have another function that is x squared minus 4. So this function is the composition of f and g of two functions, right? Here we have, let's say y is f of u, and which is sine of u, and u is x squared minus 4. Okay, so the question is, how do we differentiate this kind of functions? Now we will try to answer this question in this class. So now actually, I want to start with this example to give you some intuition about what is the chain rule. If you look at this question example, I mean the function y is equal to 3 over 2 times x, right? And we know that that's our linear function, 3 over 2. And let me just open a small window here. And this y is equal to mx plus c, right? And what is m here? Actually, m is the slope of this function, or let's say the slope of this linear function. All right. The slope means if I just draw a straight line, let's say that's the graph of the function, okay? And at this point, let's say that's point B. What does this m mean? Actually, m shows us the rate of change of this function, y, right? So that means that if you just move 1 unit in the positive direction of x-axis, right? Actually, let's say this one is 1 unit, okay? Then the change in the value of the function, what is it? It is m, okay? That means that 1 unit change in the value of x-axis, actually our function produces m units change in the value of the function, okay? That's what m means here. So that's why in this question is y is equal to 3 over 2x. This 3 over 2 is the rate of change of this function. That means that 1 unit change in the positive direction of x-axis produces 3 over 2 units change in the value of our function. Okay, so now I'm just going to make a little trick here. This 3 over 2, we can write it as 1 over 2 times 3x. Now it becomes a composite function. If I just denote this 3x as function u, right? And y becomes 1 over 2u, and our u is, what is it? The function of x. So y is a function of u is a function of 3x. Now, if you just differentiate this, y with respect to x, what is it? If you differentiate this function with respect to x, we know that is equal to 3 over 2. What is this? We know that it is the rate of change of y with respect to x, right? Again, that means that at any point, right, 1 unit change in the value of x produces 3 over 2 units change in the value of y. Simply, it's just the rate of change of the function y with respect to x. So now if you just consider this separately here, y is equal to 1 over 2u. If you differentiate y with respect to u, that's equal to 1 over 2. And if you differentiate u with respect to x, it is equal to 3. And now if you see that actually 3 over 2 is just the product of these two functions, right? 1 over 2 times 3. So that is now we have dy dx is equal to dy du times du dx. Actually, we're just actually observing here. So now if we think of the derivative as a rate of change, our intuition allows us to see that this relationship is reasonable. But still, actually, we didn't prove that. Okay, now we're going to show that actually in general, it is true. Okay, so now in this picture, you can get more idea about the rate of change of this function. Now, if you just think that we have 3 gears here given, okay, here we have this one is gear C, and this one is B, and this one is A. And suppose that C actually our Y, all right? And now it has some teeth here, right? Let's say here, if the number of teeth of the first one, the C, right? And number of teeth of B or A. What is it? How many teeth does it have? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So here we have it is 12 teeth. And how about the second one? 1, 2, 3, 4, 5, 6. So it has 6 teeth. And the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the last one has 18 teeth, right? So what does it mean? As you see here, when gear A makes X turns, right? When gear A makes X turns, right? It's actually X turns, gear B makes U turns. And the gear C makes Y turns. Like not the number of just turns, so I'm just expressing them or representing them by X and U and Y. Okay. By comparing again either circumference or counting teeth, right? We see that Y is equal to Y over 10. Right? What does it mean? It means that if actually C turns 1/2 turn for each B turn, right? As you see here, this is 12, right? Actually, then when U turns 1 time, right? But complete revolution, right? How about U? U turns only half. That means that the rate of change of Y with respect to U is just 1 over 10. And how about this X? Actually, when X turns, let's say 1X makes one complete revolution. How about U? Actually, U turns 3 times, right? Because it has 6 teeth and the big one has 18 teeth. Actually, one complete revolution for A means that U actually turns 3 times. So that means that the rate of change of U with respect to X is equal to 3. Okay. Anyway, so now let's just start with this example, and after that we will give the theorem and proof for the general case, and after that for other questions, immediately we can use that theorem. Now again, if you suppose that we are given this function is also a composite function, maybe it's a composite function of another function, whatever it is. If I just suppose that u is equal to 3x squared plus 1. At the time our y becomes, what is it, u squared. Okay, so now by using that observation, now what is the derivative of y with respect to x? Then it's just equal to derivative of y with respect to u times derivative of u with respect to x, right? So that means that the rate of change of y with respect to x is just simply the product of the rate of change of y with respect to u times the rate of change of u with respect to x, which is equal to, if you differentiate y with respect to u, that's just equal to 2 times u times. And how about u with respect to x? That's equal to 6x, right? 3x squared plus 1 is the derivative of 6x. Now, if I express everything in terms of x, 2 times, what is u? U is 3x squared plus 1. Let me just write here 6x first, and here we have 3x squared plus 1, which is equal to 12x times 3x squared plus 1. Okay, so now what's going on here? The derivative of the composite function f of g of x, f is a function of g, g is a function of x, at x is the derivative of f at g of x times multiplied by the derivative of g at x. So this is known as the chain rule. Okay, that is what's going on here. Here we have x, right? And here we have g of x. By using g function, I'm just mapping this on g and using this g mapping on y, right? If you want to differentiate y with respect to x, here it's saying that first differentiate y with respect to g and g with respect to x, and just multiply the results. In general, it is true. Why is this so? Because here we are talking about continuous functions. And this theorem says that if f of u is differentiable at the point u, that means that if you remember, it's differentiable means that the function is continuous there, right? And the g of x is differentiable at x. Again, it means it differentiable means that, again, it is continuous there. Then the composite function f of g of x, which is f of g of x, is differentiable at x, and its derivative is equal to, what is it, f prime with respect to g times g prime with respect to x. Okay, or in Leibniz notation, simply dy dx equals dy du times du dx. And if the reason why is it so, because here, right, dy dx, why dy dx equals dy du times du dx, because, for example, here, if, let me change the color here, if delta u is, okay, be the change in u when x changes by delta x, right? So that means that here we have delta u is equal to g of x plus delta x minus g of x, okay? Then the corresponding change in y. What will be the change in y, right? Because now y is a function of u is a function of x. If you make, I mean, if you just change the value of y a little bit, and also there will be small change in the value of y. Why is it so? Because continuous function, okay, because it's continuous. For example, if you're talking about, let's say, some kind of continuous function here, and this point is x, and this point is, let's say, this x plus delta x, because here the function is continuous, right? A small change, very small change in the value of x, it does not produce very big change in the value of y. And also it produces very small change actually in the value of the function. Here that's small, this one is delta y, and also it must be very small if it is continuous. And that's why our condition here is f and this g are differentiable at those points. That means that these functions at those point, at that point, they are continuous, which means that small change in the value of x or u produces small change in y or what is it, g. So then the corresponding change in y will be here f of u plus delta u minus f of u, right? So just keeping in this mind now, if delta u is not equal to zero, that's small change, right? It's not equal to zero. And what we have here, then this delta y over delta x will be equal to delta y over delta u times delta u over delta x. As if I just multiply by delta u, right? And divide by delta u. And what happens when actually delta x approaches zero? Now from here, if you just take the limit if delta x approaches zero, what is it? This delta y over delta x. That is just equal to limit and delta x approaches zero. I have here delta y over delta u times delta u over delta x, which means that actually from the first observation, when delta x approaches zero, that means that if this delta x is very small, and also this delta u will be very small. That means that if delta x approaches zero, and also delta u must approach zero, because these functions are continuous functions. Which means that now I can just write this limit for the first one, since when delta x approaches zero, delta u approaches zero. So I can just write here delta u also approaches zero. Here we have delta y over delta u times, here we have limit as delta x approaches zero. Here we have delta u over delta x. The first limit just gives us the derivative of y with respect to u, that is dy over du. The second one is derivative of u with respect to x. Okay, and this rule actually is called chain rule. All right, immediately let's see one example. An object moves along the x-axis so that its position at any time is given by this equation. Find the velocity of the object as a function of t. Okay, so here again we are talking about a kind of particle. Okay, and at any point, let's say this point is zero. At any point, the position of the function is given by this function. What is it? It is x of t, the position of the function. Okay, it says to find the velocity of the object as a function of t. It means that what's actually velocity, it is moving along this line. So here to get this velocity, we need to differentiate the position function, right? So that's equal to this. Now, as you see here, cosine, right? And this one actually, if I just label this by u, cosine of u is a function of t. So at the time, I can just write here that is dx with respect to u times du with respect to t, which is equal to cosine of u with respect to u, that's equal to minus sine of u, times u with respect to t, that's just equal to 2t, which is equal to minus 2t times sine of, what is our u? U is t squared plus 1. So it is velocity. I mean, the velocity of the object as a function of t is this function. Okay. At any time, we can just calculate the velocity. Maybe somewhere it is faster, somewhere it is slower, right? Somehow it's just moving forward and backward, forward and backward. Okay. So differentiates again this function. Again, we are just going to use a simple chain rule idea. Here our function is, let's say, f of x is equal to sine of x squared plus x. Okay, and suppose that u is equal to x squared plus x. At the time our function f will be, what is it, sine of u. Using the chain rule, what is the derivative of f with respect to x? That is just simply df, that is dy, with respect to u times du with respect to x. Now, if you differentiate y with respect to u, what is it? It's just cosine of u times, and the u with respect to x, right? X squared plus x, its derivative is equal to 2x plus 1. Now we have to write everything in terms of the original independent variable. That is 2x plus 1 times cosine of u. What is u? U is x squared plus x. Repeated use of the chain rule. Sometimes we can use this repeatedly, right? For example, here g of t is equal to tangent of 5 minus sine of t. Okay, and suppose that our u is 2t. Okay, and the w is, let's say, sine of u, and our f, or the y, is equal to tangent of let's say, not sine of u. Let me just take this w as like 5 minus sine of u. At the time, y function becomes tangent of, what is it, w. So now chain rule says that here we have three, how to say, different variables here, right? So if I want to differentiate this g with respect to t, the chain rule says that first differentiate your y with respect to w times, and after the w with respect to u times, and u with respect to t. Okay. And that's why it is called chain rule. It may just continue to maybe 3, 4, 5, 6, depending on the problem. Okay, so now we know how to calculate this derivatives. What is the derivative of y with respect to w, right? So that is just equal to, what is it, secant squared of w, right? Times derivative of w with respect to u, that's equal to, what is it, minus cosine of u, times derivative of u with respect to t, it is just equal to 2. Now, if I write everything in terms of the original independent variable, here minus 2, here we have minus 2 times, and the cosine of u, what is u? U is 2t, so here we have 2t, right? And times secant squared of w, that is secant squared of w. What is w? It is 5 minus sine of u. What is u? U is 2t. Okay, we don't have dot here. All right, and that's why actually that's the reason why we call this the chain rule. All right, so the chain rule with powers of a function. Okay, and simply if you're talking about the power of the function, and you can just actually consider this as f of u is eu to the power of n, and we know how to differentiate power function, and just comes to the front, it is u to the power of n minus 1, and after that we have to differentiate u with respect to x. So if f is a differentiable function of u, and if u is a differentiable function of x, then substituting y equals f of u into the chain rule formula leads to this formula, that is f of u with respect to x. U is a function of x. Just differentiate f with respect to u, and after that u with respect to x. And differentiating this f with respect to u, since it's a power function, that's equal to n times u to the power of n minus 1 times du dx. It's nothing new, just actually we are considering a special or particular case for that. For example, differentiate the following functions with respect to x. Let's use different color here. Which one? Let's use purple. Or, okay, A. So here our power function, here we have, let's say it is u, right? At the time, f of u is equal to u to the power of 7, right? So using that rule, that what is f prime of x? So that is first 7 comes to the front, right? Our u function, that is 5x cubed minus x to the power of 4. And 7 minus 1 is equal to 6 times. Now I need to differentiate u with respect to x. So that is 15x squared minus 4x cubed. Or usually we better write this in front, so I can just write it as 7 times 15x squared minus 4x cubed times 5x cubed minus x to the power of 4 to the power of 6. And how about question B? This g of x, g prime of x, okay? That is 3x minus 2 to the power of -1. So we have to differentiate this, okay? So by this, first, the power comes to the front. So I have -1 times differentiate inside this function. That's equal to 3. Now here we have 3x minus 2 minus 1. That's equal to -2, which is equal to -3 over 3x minus 2 squared. Right? And how about example C, sine function, right? Here we have h prime of x, 5 comes to the front, right? And differentiate sine, actually differentiate the sine function. That's equal to cosine function here. Now here we have sine, 5 minus 1 is equal to 4x. All right. Now, derivative of the absolute value function, we have already done this actually using the definition, but just here we are going to make different another approach using the chain rule. Okay, so this absolute value of x, okay, if I don't know either it is positive or negative, in another way we can actually write it as f of x is equal to square root of x squared. Okay, so which means that if I take here this one as, let's say, u is equal to x squared, and our function f becomes, what is it? Square root of u, which is u to the power of 1 over 10. So now, then what is the derivative of this function? So that is equal to, right, first 1 over 2 comes to the front. So 1 over 2 times u to the power of 1 over 2 minus 1, that is minus 1 over 2 times. Now I have to differentiate u with respect to x, which is equal to 2x, which means that this now 2 to cancel each other. We have x here, we have square root of u, right? So here we have square root of u, or that is x over square root of, what is u? U is x squared. Again, what is x squared? Square root of x squared is equal to just absolute value of x. Now from there, as you see here, x cannot be equal to 0, which means that at x equals 0, it has no derivative, okay? If x is not equal to 0, the derivative of the function is simply this. This is just another approach. And the last example, and after that I will finish this week's class, show that the slope of every line tangent to the curve y equals 1 over 2 minus x to the power of 3 is positive, right? So we need to show that the slope of every line tangent to the curve. And of course, from here, 1 minus 2x cannot be equal to 0. That means that x equals 1 over 2, right? It's not in the domain of the function. So that means I'll just consider this when x is not equal to 1 over 2. So now I can just write y function as 1 minus 2x to the power of 3, or I can just write that u to the power of minus 3, where u is 1 minus 2x. Okay. So now, then what is y prime, okay, with respect to x? That's equal to the power comes to the front. Here we have negative 3 times u to the power of negative 3 minus 1 minus 4 times du dx. If you differentiate this, that's equal to negative 2, which is equal to negative 3 times negative 2. It is 6 over u to the power of 4. What is u? U is 1 minus 2x to the power of 4. And we know that if x is not equal to 1 over 2, actually 1 over 2 does not belong to its domain, and this function is always positive, right? Because 6, you're dividing 6 by non-negative number, a simply positive number is always positive, which means that actually this y prime x means it is just the slope, right? Y prime of x is always positive. That means that the slope of everything into the curve is always positive. Okay. And we have one nice quote here, and let's finish with this quote. Education breeds confidence, and confidence breeds hope. Hope breeds peace. Okay. And as you practice more problems, for example, related to math, and especially word problems, read it, understand, and solve this in a systematic way, and you will feel some kind of confidence. And you just tell yourself that, I can understand this, I can solve this, I can do this. This gives you a lot of confidence. Okay. Guys, that much is enough for this week. Okay, next week's schedule, let me just see when we can meet this, and I will let you know about the time. Again, we are going to have 5 video lessons next week, and after next week, you will have midterm from chapter 1, 2, and 3. Thank you very much. Have a nice weekend. I will meet you next week. If you have any questions or if you want any problem to bring to the class and discuss here, just drop this in Telegram and I will prepare this and we have discussion here. Thank you very much. Bye-bye.